Alright, we're going to look at a couple more examples of using square roots to solve equations. The next one we're going to look at is a little bit different, okay, but it's going to still be using the same idea. Our next equation is going to be x minus 3 squared is equal to 16. Okay, now this time I can't really get the x by itself as is because I have this minus 3 which is inside the parentheses, and the exponent has to be taken care of before I can do the addition subtraction. Okay, now I do only have one type of x term. Okay, so what I want to do here is I want to get rid of that squared term. So how do I get rid of something that's squared? Do the opposite, right? And the opposite is take the square root. So I take the square root of both sides. Anytime you do anything, you have to do it to both sides of an equation. And so here I'm going to square root both sides. Now when I square root that, the square root and the squared cancel out, so I'm left with x minus 3. Now here's the interesting part, is that since I'm taking the square root of a variable, I'm going to end up with the positive square root of 16. And then I'm also going to need a second equation where I have the negative square root of 16. Okay? And so I've got two different answers there. And so now I'm going to have to go through and solve each one. I do know that the square root of 16 is 4. And so I've got x minus 3 is equal to 4. And then on this side, and then I'm going to go ahead and add the 3 to both sides. And so I've got x equals 7. On this side, I'll leave the x minus 3 the same because I'm going to take the square root of 16, which is 4. I'll add the 3. And so I've got x equals negative 1. So those are both solutions for x in this scenario. Okay? Let's look at another one. Let's look at another one very similar to that. Okay? So for our next one, let's look at x plus 1 squared equals 6. Okay? So x plus 1 squared is equal to 6. Okay? So we're going to do the same thing here, right? The squared thing is by itself, right? So I can go ahead and take the square root of it to get rid of the squared. The square root and the squared cancel each other out, but if I do it to one side, I have to do it to the other. So I'll be left with x plus 1 equals the square root of 6. And of course, I've got to write a second equation. X plus 1 equals the negative root of 6. Okay? Now I'm going to solve each of these separately. I can't simplify the square root of 6, right? Last time I was able to actually take the square root of 16, which was 4. This one I can't do, and so I'm going to subtract 1 from each side. And I'm going to have x equals the square root of 6 minus 1. Over here I'll do the same thing. I'm going to have x equals the negative square root of 6 minus 1. Okay? Now it's actually convention to put the whole number first. And so if we do that, we'll write negative 1 plus the root of 6. And then over here it'll be negative 1 minus the root of 6. And so those are both solutions to my equation. Okay? Let's look at one more. And then we will be done. So our last one, we're going to make it a little bit different. We're going to set it up like this. Actually, you know what? I think I'm going to do 2 because there's one thing that I forgot. So x plus 3 squared equals negative 9. Okay, this one will be a quick one. Got to take the square root of both sides, right? Because it's all by itself. Now what's the problem here? I take the square root of this side, I got x plus 3. What is the problem? Hopefully you recognize that this is a negative number. You cannot take the square root of a negative number, and therefore this is no real solution. Okay. Someday you will learn about imaginary numbers and you'll be able to solve that, but for now we're just going to say no real solution. Okay? Alright, absolutely the last one right here. So we're going to work this equation, 3r minus 2 squared is equal to 27. Alright. Now you have to make sure always that the squared term is by itself. Okay? And in this case it is. If it's not by itself, you actually have to rearrange the equation so that it is by itself. Okay? But in this case, the squared term is by itself. The squared term is this thing in parentheses. So I can go ahead and take the square root of both those sides. Okay? And so I end up with 3r minus 2 equals the positive square root of 27. And 3r minus 2 equals the negative square root of 27. Okay? Now, what we want to do here is we're going to go ahead and add 2 to both sides. We'll solve each side individually. Okay, so I'll have 3r is equal to 2 plus the root of 27. And then I'm going to divide both sides by 3. And so I've got r is equal to 2 plus the root of 27 over 3. Now hopefully you notice that this root of 27 can be simplified. That's 9 times 3, and 9 is 3 times 3, which means I've got a pair of 3's there, right? And so when I write my final answer, it's actually going to be r equals 2 plus 3 root of 3 all over 3. Now I've got to solve this one as well, right? Just because I did this one doesn't mean I'm done. So now I've got to go ahead and add 2 to both sides. So I've got 3r equals 2 minus the root of 27 divided by 3. So I've got r equals 2 minus, now instead of writing the root of 27, I already know the root of 27 is 3 root 3. So I'll go ahead and write that. Divided by 3. And that's the answer. Good luck on the work.